In this video, we're going to talk about current, voltage, power, and resistance. Electric current is kind of a weird one. They call it current, which is a C, but its symbol is actually an I, and it's just the flow of charged particles, or the rate at which charges pass through a given point. And then its units is amps. So we have this thing that starts with a C, and its symbol is I, and then its units are amps, which is 1 coulomb per second. So this is kind of weird, so just keep that in mind. Conventional current, they call that the flow of positive charges, the positive charge is flowing to the negative charge. And again, in most metals, the electrons are actually the ones that are moving, but it gives the appearance that the positive charges are moving. So that's kind of confusing, so just keep that in mind. The potential difference, they know that's known as the volts. So you'll say, it'll say like a battery with a volts of whatever, and that's the potential difference. And this one is easy. Some of them are hard, like current. Volts is easy. It's voltage, and it's measured in volts. Power. This is the same power that we were talking about back when we were talking about work. So again, it's just that rate at which energy is transferred, and so it's still measured in watts, and it's a joule per second. Except now in electricity we have power equals current times voltage, and you can put this in the triangle. This is like the worst triangle ever created, but you can put this in the triangle if you want to. So for this problem, we have a battery that is 6 volts. So we will write that down here as a volt of 6. And then it says that it's delivering a 0.5 amp current. So again, even though it's current, our symbol is I, and it's 0.5 amps. To an electric motor connected across its terminals. And then it wants to know, what is the power delivered to the motor? So we want to know the power. And so we're going to use our power formula. Power is equal to I times V, or current times voltage. And we don't have to put it in the triangle because it's already in a form that we like. So we can just go ahead and do our math. So we'll have our current of 0.5 amps and our volts of 6. And we'll get 0.5 times 6 is 3. So we will get 3 watts as our answer. And that's all you have to do. It's pretty simple compared to some of the things that we've done. We're going to talk about electric circuits. These are really the meat of the electricity stuff, so this is really important. If you need to pause and rewind and then go back and listen to stuff again, that's plenty okay, but you really need to understand this stuff. So an electric circuit is a closed loop, and it has to be a closed loop. If you have an opening right here, the current can't flow, and you're not going to have a circuit. In your house, when you turn off the lights, you're actually opening the circuit, which means the current can't flow, and then your lights won't turn on. And then when you turn on the lights, you're actually closing that circuit, which allows the lights to turn on. When you diagram circuits, there's some terms that we use. We're not going to draw these really intricate drawings like this. Physicists aren't very good artists, so we draw stuff like this. And so some of the more key terms, the conductor, this is just your wire or wherever the current is flowing. That's really important. A switch, this is kind of like what I drew on the last page, and this is what you'll see like with a light bulb or something. A resistor is really important. A lot of times they'll give you a problem and they'll say you have a resistor with this resistance, and you'll just draw something like this. We won't really use these too much. A battery is really key. Almost all of our circuits will have a battery. We have to have something to allow the current to flow. And then we usually go ahead and we make this side the positive side, the larger side, and we make the small side the negative side. So those are two things you really want to pay attention to. And then sometimes they'll say like a light bulb, and so they'll just draw something like this. Usually I just go like this, and then I like put a circle around it. That's a really bad circle, but that's kind of what I do. And then a voltmeter and an ammeter is just a circle with the letter inside. So these two are also pretty important.